Today, we're going to explore how Townsville's East End Boardwalk is performing 2 years on from construction and following record floods in North Queensland. Good morning and welcome to our webinar on Townsville's East End Boardwalk. I'm Kelly Stewart, Marketing Manager at Wagners CFT, and I'm here today with our guest speaker, Wagners CFT Project Manager, Daniel Allen. Daniel is Wagners CFT's most experienced project manager, gaining a wide breadth of experience in the construction industries since 2011. Daniel is passionate about the use of sustainable materials such as FRP and geopolymer concrete. Possessing strong construction methodology knowledge, Daniel strives to provide a comprehensive end-to-end delivery from the design concept stages to planning and construction, bringing unique insights and expertise into niche sustainable civil projects across Australia. We're also joined by Wagners Composite Fibre Technologies General Manager, Australia New Zealand, Ryan Leeson, who will be facilitating today's Q&A session with Daniel. Welcome, Daniel and Ryan. Before we get started, just a few webinar protocols. We are recording today's event and will make the recording public via the Wagners CFT YouTube channel. You can ask a question anytime during the webinar via the chat bubble at the top of the screen. However, we will hold your questions over to the end of the webinar presentation for the Q&A session. And for anybody having difficulties accessing the chat facility, feel free to text me your questions directly on my mobile phone. I'll just pop that number into the chat facility there for you now. So let's dive in. Daniel, if you'd like to start off by telling us a bit more about Townsville and the East End Boardwalk.
Yeah, I'll jump in. I'll just share my screen. So yeah, thanks for the introduction, Kelly. A lot to actually live up to there. As you mentioned, today I'll be discussing the East End Boardwalk. So it's also known as the Waterfront Promenade Stage 2. It's a 280 linear metre boardwalk along Townsville's Ross Creek. Like you said, a quick notes on Townsville. It's known as the second capital of Queensland. It's the largest city outside the southeast of Queensland. It's a port city with over 200,000 people. It's famous for its big old Castle Hill, a couple of metres short of a mountain, up there in the top right. The North Queensland Cowboys, not having the best year in their home Queensland Country Bank Stadium down there on the left, and its proximity to Magnetic Island, just 8 kilometres off Townsville's coast. So as with most northern Queensland cities, it's prone to severe cyclone events and rainfall events, and often resulting in common major flooding. A couple of also quick notes on Wagners' background in Townsville. We're a staple boardwalk, stairwell and bridge contractor in Townsville. We've had a long history of completing projects in the area. I think there's 3 boardwalks or bridges along Ross Creek alone, made out of FRP, completed by Wagners. We also have a long history with a concrete batch yard and a warehouse for cement located in Townsville. So it's a bit of a second home for Wagners. The project scope for this one is a design and construct of a new 280 linear metre long and 5 metre wide marine boardwalk. It delivers a waterfront connection from the Flinders Street East car park and extends along the Ross Creek edge through to the Reef HQ Aquarium. It's a part of a larger waterfront promenade network project being completed by Townsville City Council. So as I suggested, stage 2 of that. There's a requirement for design considerations for future works, which was one of our major items, which included Ross Creek Bridge. So it's a connection across Ross Creek to Palmer Street. There's also connection into the local precinct and the boardwalk continuation to the Magnetic Island ferry. It also included non-destructive structural integrity testing analysis over 100 linear metres of existing timber jetty and concrete structures. And a partial demolition rectification of the existing structure to try and increase design life of the existing structure. Just a quick overview of the project location. So as I said, it's located along Ross Creek. It runs along the Flinders Street car park. As you can see there, just in front of the Mad Cow on Flinders Street, so the main drag. It passes just by the former post office and trading building, also known as, or previously known as Bullwinkle's nightclub. They're right in the middle, and finishes in front of the Queensland Museum, Tropics Museum, and just short of the old Great Barrier Reef Aquarium. It's just a map there of the future planning aspirations by City Council. So obviously you can see there all the connections and the proposed future connections. So one of the, I guess, the main benefits is trying to connect the cruise terminal up there in the north, all the way through to the stadium, and connecting all the major eat and entertainment areas along the Ross Creek. Just a note there on why Wagners was selected. I will read it because it is from Townsville City Council, and it's probably the nicest words we've had, I think. So Wagners CFT was selected as the principal contractor to build stage 2 of the waterfront promenade, with the inclusion of several local subcontractors. The project used innovative products and technologies, including composite fiber technology that incorporates reinforced polymer products that are ideal in a coastal environment owing to their resistance to rust, rot, and corrosion. These products were manufactured by Wagners CFT in Queensland and offer enhanced environmental solution compared to traditional building and construction materials, providing an expected 100-year design life for the engineering and materials. The structural fiber reinforced polymer materials have been coated with a unique product that utilizes technology, providing longevity and durability when compared to traditional construction materials. This is particularly beneficial in a coastal environment like Townsville, where factors such as UV conditions and salt impact on built infrastructure. So couldn't have said it better myself. Thank you, Townsville City Council. How were we engaged? So Wagners were engaged under an ECI as the initial tenders exceeded funding expectations. The project funding needed to be maintained. So we were, we consulted with major design and construction subconsultants and contractors to complete first up optioneering and cost analysis. On the end of that, Wagners were then engaged under design and construct contract for the works. ECI and optioneering is quite common for Wagners, having designed and manufactured Wagners CFT for over 15 years. So it's quite a common occurrence and something that we see a lot of value in. Just a brief overview of our project team. So our project engineer and site managers up on site were Matt and Mark. We had a lot of support from our design team, Ali, Jason, and Chirag. Some of the critical subconsultants and subcontractors were iCubed in the design space, and then major subcontractors, TGS Marine and PW Landscapes for the marine piles and the land structures. So we had a lot more local contractors. Too many to count. I think we had over 30 in the end, so quite an encompassing project. So project challenges, as the webinar title suggests, the boardwalk had to be designed around flood impacts and the levels of Ross Creek, while trying to adjoin to future planning levels and managing costs. So quite a difficult one. As with most projects, the difficulty was getting in out of the ground. So geotech issues and foundation design considerations were a major. The depth of rock in the area was 4 to 5 meters. And socketing into the rock was required and subsequently affected some of the heritage listed buildings I talked about earlier, and the private property owners and businesses close to the boardwalk. We actually had vibration monitoring equipment on those foundations of those buildings for the duration of the project. Another, mitigating factor was the environmental impacts from drilling into rock that had to be considered, and largely led to a lot of our foundation decisions. Some of the minor items were the older large stormwater surfaces in the location that need to be bridged. So quite a considerable one for a minor one. And then another one, during construction, we had a rock wall failure. One of the buildings runoff led directly behind the rock wall and resulted in it slipping. So that happened while we were on Christmas holidays. So it was a fun one to come back to. As I suggested, one of our most major design risks was flood impact. It required a high level structure rising out of the creek bed up to 6 meters as a result of the Q100 RLs. It really shaped our design considerations for deck level connections and foundation types. And just a note, on what kind of damage the a higher level flood can do in Townsville. That's Ross River, which runs directly into or runs off to cross Ross Creek, just showing the kind of destruction that can occur. So our second major challenge was, as I suggested, was the geotechnical conditions, which we were able to explore through the ECI. So very fortunate to be able to explore that up front. Really led into some of our great value engineering. The tender provided the initial testing and borehole data completed by the client. Wagners further investigated the area with some additional boreholes in the car park and down towards the buildings. As you can see, the top layer there is a sandy fill gravel, which couldn't reliably be used. Many of the piles would need a socket deep into the rock layer of depths up to 5 meters. Just some of the design and value optioneering we considered in the foundation space. So I guess initially the tender was a 2-pile bent system for a full marine structure. One of the great positives, and I guess why we started with that, was the mitigated project risk of moving away from the older structures, such as the revetment wall and the heritage listed buildings. Unfortunately, the cost was quite prohibitive, requiring up to 70 marine piles in the waterway. We then, I guess, looked at halving the marine piles directly and providing a monopile system. It increased cost and foundation risk with a required 600 mil board pier that also made it prohibitive. It also, one of the major downsides of the monopile design and where it was situated was the limited accessibility for future connection considerations. So we would have had to, I guess, put bridges or truss bridges in for any kind of connection from the buildings. And it's, I guess, in a stark comparison to the 2-pile system with one on land and one on marine that we landed with. Originally, we had a smaller foundation on the land and then a larger foundation on the marine, socketing into the rock, effectively cantilevering. We decided in the end to reverse that and provide a large foundation in the car park. Just due to the access, we were able to access with a large machine. We installed a generic 400 mil diameter steel reinforced bore pier, socketing into a dense layer of up to 1.2 meters. So the steel casing was used to sleeve to the rock layer, so encompassing all that fill before the rock hammer was created a clean socket for the cage. And as I suggested before, we had vibration monitors allocated to the businesses and buildings around the area, which were clear when completing this section. But as we got closer to the buildings, we started to see some higher results. That led to, including the rock wall failure, but it led to changing the design in the location behind the buildings. And effectively, it was due to, we had a very confined space, not as much room to move in there. We obviously were hitting higher readings on the noise vibration monitors. So we're starting to see a little bit of impact on the buildings, which we wanted to avoid. So we changed to a 90 mil cased micropile with a concrete foundation that seals it all together. So a smaller machine was used to great result. We reduced the footprint and environmental impact in that area by changing to those micropiles. It was also very cost effective and allowed for program acceleration in that area. So overall, a very good change of ideas. And then in the marine side, the marine piles were designed by project partners in conjunction with subcontractor TGS Marine. They used a very innovative design and pretty brave design of its. I believe it's the first of its kind. A steel casing driven into the initial rock layer, then micropile and grout filled down through the center. So the micropile boring into the rock through the steel casing, and then being chummy filled with grout all the way to the top. They also pre-installed fins that were pre-welded in the steel casing to remove the amount of grout required. So one of the real benefits of the is the reduced impact to the environment. Obviously, didn't have to have that 400 mil rock hammer smashing away into the rock layer in the waterway. So which was a great outcome for us. They used a small 191 mil rock hammer for the micropile, and then fed the micropile down with a sacrificial head, and then closed it off and poured grout. So it all went to plan, and they were able to cut the piles down to level and provide us a really good outcome. One of the items, apart from the micropiles, which were, I think, possibly a world first, what was a shining element of the boardwalk design were the long 12 to 13 meter trusses that were used to connect the micropiles. It allowed the piles to have a reduced design, so allowed installation of the deck via the trusses, as trusses were pre-installed. So we had a 1450 deep truss connecting the micropiles, as you can see in the pictures there. They were pre-installed, and then we were able to drop the deep bonded headstocks on the other side on the land piles, and then we connected all through with the deck. So yeah, just a couple of pictures there of the CFT deck and structure. We were obviously greatly owing to the lightweight yet strong CFT deck. They could be lifted in full deck systems and placed into put into place. The braces were then connected to the structure and bolted down. The prefabricated elements was probably a real win on the project. It allowed us to have very controlled construction programming and avoid title restrictions, which obviously reduced cost in the end. So a huge benefit was also the modular aspect of the deck that can be removed for future planning considerations, such as the Ross Creek Bridge that may take out one of those sections and then put a bridge in its place going the other way. I guess one of the items that we're here to discuss, Townsville's recent flood events. Don't, I guess, note these lightly because they're still happening currently, but quite often North Queensland gets hit with these kind of heavy periods of rain during the wet season. But the sustained intensity of these events has been both remarkable and devastating. In early February, Townsville received almost 300 mil of rain in 24 hours, and all the way up to 710 in 72 hours, which is in some locations up there are rarer than 1 in 2,000 year event. It's currently undergoing a current rain event. So there was a new record actually set just last Wednesday with the heaviest day of rain in any month in 27 years. So really starting to see considerable downpours in the last 2 years, which is, I guess, times in very closely with the completion of our boardwalk. Even still, I guess just the other day, there was the heaviest rain occurred between 1 and 9 a.m. With almost 250 mils in 8 hours. So some of those impacts are still ongoing today, and we don't know the full result of those. But just, I guess, some notes on flood impacts to our structure. We saw that levels of the Ross Creek were between Q100 and Q200 events, with levels rising above 3 meters. So, you know, as per our design, our trusses and deck is to be inundated with water. It's happened now twice. At least the trusses have been inundated twice in the first 2 years of its life cycle. So pretty impactful, especially when you consider a 1% AEP design level occurrence. So it's a 1% chance to happen annually. So I think we might have hit our mark already, hopefully. I guess one of the great things and fortunate things in what we designed for is that the deck is designed to take those impacts. We haven't seen any issues with design implications with the structure on its completion. So really a very fortunate and great result for the whole team. Just some notes from our design and optioneering and construction results. So over $3 million reduction in price from initial tenders. So a 30% reduction in cost, which I know our client was very happy with. We were able to risk mitigate from the initial 70 large piles just to 16 marine piles and 19 land piles, really using the longer truss connection back to a really kind of bulked up deck that went back into the larger land piles. We also further down the creek were able to reuse some of the existing infrastructure. We had integrity testing return a real positive result on that. And then, like I said just before, one of the majors is the CFT sections were modular and can be removed for future planning and considerations. Just a picture there, obviously with the marine structure down below, and the beautiful big Castle Rock in the background. And then just to close out, I guess some special thanks, Townsville City Council. Your brave decision to allow us to engage in an ECI was beneficial for all parties. So thank you to them, and then our design and construction partners. So we definitely weren't alone in this one. Special considerations, like I said, to TGS Marine and their design consultant project partners, and our long-term designer, iCubed, and our design team locally that were fundamental in providing the design that we ended up with. And that's all I have for you today. So that's the end. Any questions, or over to you?
Thanks, Dan. We're going to take a little break here for a moment, and I'll jump in and just share my screen, give you a moment to catch your breath and have a drink. So I'm going to, before we dive into the Q&A session of our webinar, I just wanted to really quickly tell you where you can find more information about our pedestrian boardwalks on the website, and tell you a little bit about a unique challenge that Wagners CFT has recently issued. So whether you need boardwalks through mangroves or boardwalks around coastlines, Wagners can supply the perfect boardwalk infrastructure for you. We've designed, supplied and constructed FRP boardwalks right around the globe, and our structures have proven their unique ability to withstand the harshest of environments while providing low maintenance, long life assets for the local community. So if you'd like some more information about our pedestrian infrastructure, use the QR code that's on the screen there now, or I'll make sure to send you a link to the website pedestrian boardwalk bridges page on our website in the follow-up email today. Have you got a project where trusses are not feasible, spans are greater than 15 metres, or access to the project site restricted to large machinery? Wagners CFT's new fibre-reinforced polymer supergirder could be the answer to your problem, and we're throwing down the gauntlet to put your project up to be the first in the world to use this technology. If you've got a marine structure, a boardwalk through a national park, or hard-to-access project site that could benefit from the FRP supergirder, contact us now using the QR code on the screen, or I'm just going to pop a link in the chat for you as well. We've got, there's also a great story about the development of the FRP supergirder. So I'm going to pop that in our follow-up email today as well. Watch out for that one. It's a great read. I'd now like to introduce you to Wagners CFT General Manager, Australia and New Zealand, Ryan Leeson. Ryan is going to facilitate the Q&A session of the webinar for us today. Hey, Ryan, we got some questions there.
Very good. Thank you, Kelly. We'll pile straight into it, and thank you, Dan. A bit more about the micro piles is the first question here. Since they were first of their kind, were there positives and negatives identified when working with them? And I guess would you use them again on another structure?
Considering we're hopefully about to use them again, I'd say definitely we would use them again. In the marine sense, yeah, I think it was fantastic. A lot of reduced impact to the environment, obviously knowing too that less than 200 mil rock hammer that was sacrificial in going down to the board, boring into the rock layer. So huge win on that front. They were able to just locally silt fence around the casing, so to absorb any kind of fill or grout that popped out of the pile. But we actually didn't really see any of that. It was cased all the way down into the rock and pushed into the rock bed. So no, very, very much just positives from that point of the micropile and the marine sense. And then on land, obviously, like I said, just on the back of those buildings, having those micropiles in the smaller machine in that area, hugely beneficial, especially considering the rock wall failure that previously we didn't have the appetite of taking the 25 tonner down in behind the building. So no, nothing but positives for the micropiles.
And I guess the follow up to that one, what happens to the steel casing? So again, it's purely below water level, I understand, but will that, I guess, corrode away, and is the concrete there to support it in the longer term?
No, so it's actually sealed in. It has a HDPE sleeve that goes on the outside of the steel casing, which gets pushed down and effectively to the socket level, and then it's taped off or capped with a HDPE cap and like plastic welded around the rim, and yeah, so it's not going to have any, I guess, effect or water getting into it over the 100-year design life. That's what it's designed to do.
Okay, one of the other ones I found interesting was the demo. Can you run through the demo a bit? And I think there was an underwater chainsaw or something used from discussion to cut piles. Just want to run us through the demo phase and some of the work that was done there, and also maybe what happened to that timber. Yeah,
so we had the old dock just in front of the Queensland Museum located there, which I briefly mentioned, didn't touch on too much. We had, I guess, a look at trying to revamp it, but structural integrity for that item was failed, unfortunately. So the decision was made to remove it. So they came in and dismantled the deck from land, and then they were left with large timber piles. So they actually had marine divers in there and marine chainsaws to remove them at bed level. They were cut off below and then just craned out individually. And then I guess the other portion of it was what the timber was done. So it was actually sent around to men's sheds in the area and reused for various furniture and equipment as they do with it. So yeah, really good outcome for the project.
Okay, and a bit about the prefabrication of the bridge sections or the modular sections. Was that to reduce the amount of overwater and on-site construction time? Because that's sort of a gap filling activity, particularly wet weather, as you spoke about in Townsville, being able to use it on a hard stand area rather than over water. Just maybe run us through some of the benefits and challenges you had with that approach.
Yeah, so like I mentioned, having that car park there is quite extensive laydown yard, probably more than what we've ever had on any other job. We had full access to, I think, 150 linear meters of the boardwalk via machines and cranes. So we were able to have the structures being built in the car park in modular format. Like you said, one of the big benefits is not having to work over water or minimizing the work over water, but also working outside the tidal restrictions. So quite a severe tidal area, dropping, I think it's 4 meters up and down throughout the day in Townsville. So we got to mitigate that and have the crews just working as we needed in the car park, which is a huge benefit.
Fantastic. And just on the flood performance, so the flood velocities through that area, is it more a surge area, or does it actually have some flowing velocity through there? And how did they go about cleaning the structure? Did they just, I guess, lightly gurney it or hose it down to get the mud off it, or how did that all happen?
I guess the first part of it is it's more of just a constant 1 meters per second flow through that area. The flow level doesn't increase that much as a creek. It's more of a air flood height that increases and then inundates the deck and the truss. And as for cleaning, I'm not totally aware exactly what they've done. I've not seen final pictures of the site, but I know from earlier days they were just getting in there when a decent flood happened and they were just gurning it off and washing it. So there wasn't much, I guess, maintenance or mitigation in relation to that.
Fantastic. Okay, well, I think that has us covered for questions today, Kelly. Appreciate you presenting and sharing that with us today, Dan.
No worries.
Thank you. Dan, thanks so much for your presentation today. It does look like we've reached the end of our questions there. So before everybody goes, I just wanted to, if you'd like to share your thoughts on today's webinar, please feel free to complete the feedback form on the QR screen, on the QR code with the QR code on the screen that I've just popped there. And I've also popped that URL link into the chat facility as well. There's also options if you'd like to be a guest speaker with Wagners CFT's monthly webinars. Fill out that form, give me a call, reach out to me on LinkedIn, however you want to connect with me. I'd love to hear from you, and we'd love to share your stories about construction and builds and projects that are going on around the traps as well. Really quickly want to let you know, coming up in April, we're going to be drawing on the extensive knowledge of Wagners CFT Technical Lead, Dr. Ali Mohammed, and Chief Technical Officer, Michael Kemp, to learn everything we need to know about piling with Wagners FRP piles. So if you're interested in attending this webinar, use the QR code that's on the screen there now to secure your free online seat for the webinar or receive a recorded copy of that webinar. I'll make sure as well that link to that webinar is shared in the follow-up email that will come around today as well. So that concludes our webinar today. Thanks so much for coming, and big thank you to Dan Allen for his efforts putting that presentation together. We're going to go out on that fantastic video showing East End Boardwalk in Townsville there, and we look forward to seeing you next time. Bye now.